There are two different formulas we can use when we find the area of a triangle, and I'll explain the difference between the two formulas. They're technically the exact same formula, okay? The first one is that the area equals the base times the height divided by 2. The second way we can write the formula is that the area equals 1/2 of the base times the height. Now, if you take half of the area or you take the area and divide it by 2, those are the same. It's just two different ways to write it. And I'll explain why we have two different formulas in a minute. But the first thing I want to do is explain to you why this formula works. Think about what you know about base times height. Base times height is the formula we use to find the area of a rectangle. Okay? So if I had this rectangle and I wanted to find its area, I would do base times height. Same thing with this parallelogram. To find the area of a parallelogram, I would do base times height. But I don't want the area of a parallelogram. I want the area of a triangle. So that's why we divide it by 2. Look what happens if I move this out of the way. Okay? You can see that this rectangle is actually made up of 2 triangles. In this parallelogram, same thing, made up of 2 triangles. So if I find the area of the whole rectangle, base times height, and then divide it by 2, I'm actually finding the area for one triangle. Same thing over here. If I find the area for the whole parallelogram and then divide it by 2, I get the area for each triangle. So now let's use this formula and take a look at it. Okay? This formula here, the base times height divided by 2, you're going to use this formula for triangles that have sides that are measurements that are whole numbers and decimals. Okay? So if you look at this triangle, it is all whole numbers. If you look at this triangle, it has decimal measurements. So we're going to use this formula. We're still going to follow that FSA model where we write our formula, then we substitute, then we write our answer with a label. Because it's area, our labels are always going to be square units. And the other thing is, remember, our base times our height have to form a right angle. So when I look at this triangle, I can see this is my base and this is my height. And this slanted side is just a number that's put in there to mess me up, just in case I don't know what the base and the height are. So we never use the slanted side measurement, just like with parallelograms. All right, so let's look at this. We have area equals the base times the height divided by 2. So next step is to substitute. My base is 12, my height is 16, and I'm going to divide that by 2. Now remember when we did the area, I said it's okay because we can use a calculator. That's still going to be the case here. So once I've got my substitutions done, I can use the calculator to do 12 times 16 to give me this answer. So my area is going to be 192 divided by 2. And then I can do this last step, this divided by 2 on my calculator, and I can find out that my area equals 96, and again, centimeters squared. Okay? Now let's take a look at this one. I'll move my calculator out of the way here. We're going to start off with our formula. Area equals base times height divided by 2. So my base and my height form a right angle. So these two measurements right here, not the slanted side. So if I do my substitutions, my base is 7 1/10, my height 8 2/10, and I'm going to divide that by 2. So now I can pull my calculator up here. Let me try to move it out of the way. So I'm going to do 7 1/10 times 8 2/10 is going to give me 58 22/100. So my area is 58 22/100, but remember, I need to divide that in half. That would be the area for the whole rectangle, base times height. But I just want to divide it in 2 to find out my triangle. And when I do that, I see that my area is 29 11/100, and this one is meters squared. Okay? So remember, this formula we're going to use when we have whole numbers and decimals. Now the second formula we had looked like this. It had the fraction, 1/2 of the base times the height. This formula we're going to use when we have fractions. Okay? So if we look at this triangle right here, we start off again with our formula. And since we have fraction measurements, we're going to do 1/2 base times height. Now my base and my height form a right angle, so we're not using our slanted side here. My next step is my substitutions. So I'm going to have 1/2 times my base, which is 4 1/5, times my height, which is 2 1/2. Now when it comes to multiplying fractions, I can't multiply mixed numbers. So I'm going to have to take these two mixed numbers and change them to improper fractions. So it's going to be 1/2 times, remember 5 times 4 is 20, plus 1 is 21 over 5. And then 2 times 2 is 4, plus 1 is 5 over 2. Okay? Now, it's really important for me that I simplify this before I multiply, because otherwise I'm going to get some really big numbers. So remember, if I'm going to simplify before, I can look for any numerator and denominator that has a common factor. And I know that this 5 and this 5 both have a factor of 5. So if I divide this by 5, I get 1. If I divide this by 5, I get 1. And now when I multiply this out, 1 times 21 times 1 is going to be 21. My denominator is going to be 2 times 1 times 2, which is 4. So my area is 21/4. Now I can't leave my fraction as an improper fraction. So I'm going to take this and turn it back into a mixed number. To do that, I take my numerator, divide it by my denominator. 21 divided by 4 goes in 5 whole times with 1 left over. So that 1 is my new numerator. My denominator stays the same. So 21/4 is the same as having 5 wholes and 1/4. So this area of this triangle is 5 1/4 centimeters squared. So remember, two formulas for finding the area of a triangle. The one that has the fraction, 1/2 base times height, is going to be used when you have problems that have fractions. The other formula, base times height divided by 2, is going to be used for whole numbers and decimals.